Okay, I wanted to show you this problem. What the heck are we? How about this one? There we go. Okay. So in this problem, I think that the implication here. Wait a minute. Where's my? Oh shoot. Let's see if my pen is working. No, I'm not gonna be able to do it over here. All right, hold on. I like to do it on the one with my face, but no. All right, let's try again. So the implication of this is that we're going to do the disk method and take little thicknesses of dy. So basically, we want to think in terms of y, which means that the radius of these disks, which would naturally be x, needs to be expressed in y. Second of all, we're going to have to do a subtraction situation because we're going to have this sort of inner guy where we have these disks. That's going to be subtracted out of the outer guy. And then that's going to give us this kind of cool V vase shapey thing where we, go around in a circle here. Okay, so in other words, when I set this up, I'm going to do we can call the sort of outer one pi r squared dy minus the pi r squared dy, the inner one. And again, the r here needs to be expressed in terms of y. Now, in the outer one, it's nice because x, which is r, is y, right? Y equals x. So this is just pi y squared dy minus, now the inner one is, we got to do a little bit of manipulation, 1/8 y equals x. So the radius is x, r, little r. So this is 1/8 y. So it's pi over 8 y squared dy. Well, in fact, then we really have 7/8 because that's the same thing, 7/8 y pi y squared dy. So this is the integral that I need to do, and I need to go from 0 to 24. So that should be my integral. And wait, this is the right answer or is the wrong answer? So I got 63/64. Oh, yep. All right, made a little boo-boo there because if r is 1/8 y, right, then this is where I made the mistake. Pi times 1/8 y squared dy. So this is pi times 1/64 y squared dy. So that's where we get, we've got pi 1 minus 1/64. That's where we get the 63/64. And then to integrate that, I wouldn't think that'd be a problem, but 63y cubed over 364, we got the pi, just can simplify down 21 pi over 64 times y cubed. And by the time we stick the 24 in there, we're going to end up with this number, I assume. 21 times 24 cubed divided by 64, 4536. So to recap, I guess, you know, in this could have been a shell question. I mean, so they're sort of forcing you into this by the dy. The dy tells you the thickness issue, right? If it's dx, then the thickness is this way. If it's dy, then the thickness is this way. So then your area needs to be the other direction. And since there's not a continuous disk that goes for this part, we need to do it as two disks, the inner disk and the larger disk. So hope that helps. Let me know if you have more questions about this kind of integration. Fun stuff.